Another way to say this is that this is Disney's cost of equity. They need to make this amount in order to compensate their equity investors for the risk that they're taking. Now, what happens if you don't make this? Technically, in one way, nothing, right? Because equity investors they're not obligated to 9.95%. However, if you don't make this for them on average, you're going to have unhappy stockholders. Eventually, they're going to leave, and you're not going to be able to attract new ones, so the stock price is going to lower, and ultimately, you're probably going to lose your job. Right? So while technically there's no official rule that you have to make 9.95%, unofficially there kind of is. So let's look at all this information once more for a different company, for Tata Motors. This is from Bloomberg. And so here we have the linear relationship between Tata Motors returns and the market returns. And then it's going to give us all the different pieces of information that we need. So first, the raw beta, right here, is 1.83. So we know that's what the beta is. We also know the standard error of the beta is 0.161. That gives us the standard errors that we're looking for. And so here, we're using that information. We're 67% confident the beta is between 1.67 and 1.99, which is just adding and subtracting the standard error. In addition, we also see that the R squared is 0.69, or 69%. So we use that here, because it tells us that 69% of the risk is market risk, and 31% is firm-specific risk. We also notice the alpha. The alpha is right here, 2.282. And so we can plug that in to Jensen's alpha. And what we're going to find is that we're going to take 2.28, subtract the risk-free rate at the monthly level, 4% divided by 12, multiplied by 1 minus beta, or 1 minus 1.83. That gives us the Jensen's alpha of 2.56%. If we annualize that from the monthly level, we're going to find an annual rate of over 35%. Now that's an incredible rate, because that's saying, in general, during this period, the firm did 35% better annually than was expected. The fourth and final thing we're going to use is all this information, specifically at the beta once again, to figure out what is the expected return. And here it's in rupees. So estimating, first we plug in the risk-free rate plus beta times the risk premium. Both of these have been estimated in the previous class. We're going to find the expected return is 19.73%. That means that Tata Motors has to make nearly 20% annually each year to compensate equity holders for the risk that they're taking. So make sure you understand this, right? These are all different pieces of information that we're collecting from this regression, and we're plugging it in and using it in different ways in each of these 4 boxes. So know how to estimate each of these boxes from the data. With that, I'm going to stop and offer 2 different questions. So I suggest you pause here and try each question yourself. Alright, so the first question is making sure you understand how do you estimate Jensen's alpha. Now we need a few different things here, right? From this information we need the risk-free rate of 3.6%, we need the alpha at negative 0.15, and we need the beta of 1.80. What we're going to do is first estimate the monthly risk-free rate. So 3.6% annually divided by 12 is 0.3%. Second, we're going to estimate Jensen's alpha. Take the A from the regression, subtract off the risk-free rate times 1 minus beta, and we're left with 0.09%. The third step is multiply by 12 to re-annualize. You could also compound to get a more accurate answer. For our class, multiplying by 12 is generally going to be enough. And so, going back to the question, we would see these different answers, and we just showed the answer is 1.08% better than expected, which we got from right here. Alright, turning to the second question, The second question is in many ways actually the tougher one, even though it's conceptual. Because what it's actually asking is that you really understand R-squareds. So here's two different firms, Cypress Industries, which is the firm above, and a second company, which is a roughly equal size. Now the R-squared for Cypress was 35%, the R-squared for the second company is 15. If you run a regression in a couple years after they've been acquired and joined, which of the following would you expect to see happen to the R-squared of the combined company? Now at first it might seem like it would be in half, right? You're going to take 35% from the R-squared, you're going to take the 15% from the second R-squared, split the difference, and it's 25%. That sounds correct, but it's actually not quite. And the reason is because these companies are in very different industries. Cypress is a chemical company. The other company is a technology company. And what that tells us is that they're in very different markets and they're covering different parts of the market return. So combined, they're covering more of the market than they were individually. And that means that it's actually the rate is going to have to be higher than 25% because they're recovering more of the market together. So D. Now, this might not seem very intuitive, but we can extend this argument up to not just thinking about two firms, but thinking about like 20 firms. Think about 20 firms of equal size in all different industries. Okay, so they're all covering all 20, let's say, of the industries of the world. Now, if they all join and create this giant conglomerate, their R-squared is not just going to be the average between them. The R-squared is actually going to essentially be 100%. Why? Because when you put all of these firms together, they're covering all the different industries of the market, so essentially they're going to have the market return. And so if you think about this not with the 20, but just back to the 2, you already realize the R-squared is going to have to be larger than it would be if these firms were in the same industry, because they're covering two different industries now. Alright, so the second topic is beta fundamentals. This is going to help us understand the topic for lecture 13, which I'll warn you now is already a fairly complicated topic. But what we need to understand is that what is a beta? Meaning, where do the high betas and low betas actually come from? We're going to think about different reasons why betas might be high or low, and then use that information to see if we can kind of understand and how betas will change depending on the company that we're looking at. So here's what we're thinking about today. These are betas for different types of companies. Some betas are high, some betas are low. So let's start in the middle. GE. GE has a beta of 1.15, which is pretty close to 1, right? It says that it's fairly close to the return on the market. The reason is because GE is a very well-diversified company, right? It has a lot of different industries. And just like I argued before, if you're a company in a lot of different industries, then you are going to look a lot like the market itself. So your beta is going to be essentially 1. So why is it a little bit above 1? Well, it's actually because of GE Capital, the financial arm of GE. GE Capital is fairly well levered, meaning they have a lot of debt. And as we'll talk about in just a few minutes, high debt increases your beta. So it's not quite, it's actually a little bit above 1. Let's think about the high end here. Bulgari. Bulgari is a fancy watch company. And so a beta of 2.45 tells you that it moves really strongly with the market, right? If the market's doing well, Bulgari is doing very well. If the market's doing poorly, Bulgari is doing very poorly. This is known as a discretionary product. It's a product that people only purchase when they're pretty wealthy and can afford to, right? You don't need to necessarily buy a fancy watch, but people choose to when they can. So that means that it's going to be very dependent on what's going on in the market and how wealthy people are. Okay, instead, let's move down. Let's think about these companies right here, ExxonMobil and Philip Morris. These companies have a beta that's less than 1. Both these companies are in industries that, for the most part, people need. right? ExxonMobil is going to be obviously an oil company primarily. Philip Morris is a cigarette company. Now, while there is some variation depending on like how the market's doing, for the most part, people are just going to buy gas to get to work, right? And so they're not that related, the markets and how gas is doing or oil is doing. Cigarettes are even more so, right? If you have kind of an addiction to cigarettes, you're going to smoke cigarettes regardless of how wealthy you are, right? So it shouldn't be that correlated with the market. Now let's think about the extreme right down here. Harmony Gold Mining has a beta that's below 0. What that actually tells you is that when the market's doing well, the gold mine's actually doing kind of poorly, and vice versa. This is because gold is a hedge. People buy gold in recessions, right? Or in particular, they often use it to hedge against inflation risk. So it's actually one of those things you buy only when the market's doing poorly. So you actually get a beta that's actually negative, which is uncommon, but it happens anytime you're looking at an industry that's used as a hedge against recessions. So those are kind of the different arguments for why betas might be high or low. I'm going to break down to 3 specific fundamentals that we're going to look at in this class. The first is product type. Now, product type essentially says that the beta for a firm really depends upon the products and services that firm offers. So if you look at a company that has very cyclical demand, right, that only sells things when times are very good, then you're going to have a high beta. Another way to say it is firms that sell more discretionary products will have higher betas than firms that sell less discretionary products. So this was the argument for Bulgari, right? A watch company is going to be very cyclical, and this is going to be very different from what we looked at, like, right, Philip Morris or ExxonMobil, which are less discretionary, right? Those are companies that sell even in recessions. Second, operating leverage effects. This is a little more complicated, but the argument is that another thing that really drives betas is whether your costs are fixed or variable. Other things remaining equal, higher operating leverage, right, so higher fixed costs, result in higher betas. Now to see this, consider 2 different firms. We're going to think about firm A and firm B. Now imagine they both have the same revenues. The revenues are going to look like this. Sometimes they're good, sometimes they're bad. But their costs are going to be different. Firm A has variable costs, which means that when they're selling a lot, they also have high costs. When they're selling little, they have low costs. So their costs are going to look like this. Firm B is going to have fixed costs. So no matter what's going on in revenues, we're always going to see that, let's say, the costs look like this. Right? That's a fully fixed cost. It doesn't change. Now, what's going on with profits? Firm A, the profits are pretty much constant, right? At any given point. This is the difference, right, between revenues and costs. So it's actually not really dependent on how much revenues are coming into firm A, right? And if it's not dependent on revenues, then it really isn't very affected by the market. Who cares if there's a recession or not? Their profits are going to be about the same. Let's look at firm B. Firm B is very dependent on what's going on in revenues. In a bad time, like right here, sorry about that. Well, I think I just lost that, but in firm B, like we just saw, the revenues are kind of all over the place, but the costs, right, don't change. So in a bad period, like right here, you're losing a lot of money, right? Because this is all loss. In a good period, you're making a lot of money, right? That's all your gains. Then you have another bad period, and you're